Yeah, Thunder, I think a lot of your first were before I started tracking it, unfortunately. And hey, Joseph. Okay, so it it is hot as balls out today, so I'm just gonna use paint. I'm not gonna use the whiteboard because I just don't feel like standing up and doing things. 3 watch streak. Oh, thank you. Happy Tuesday to you too. Um, Thunder, are you gonna have a question or are you just chilling? Because just chilling. I'm going straight to studying. You know, I feel like I should, like, 2.6 is so, like, simple that I feel like I should just do it, you know? It's just a formula question. Race are the integration unit, reverse power rules fun. Oh, nice. Yeah, there's some really neat integration techniques. It's not nearly as straightforward as taking a derivative. Oh shoot, don't do that. Before we get into that, we need to look up the diameter of a basketball. Dimensions.com. Sure. And next we're gonna put the meter or the the diameter in terms of meters. What does dia mean? What does that prefix mean? Through, across, from point to point, completely. So if you have a diameter, maybe meter is just like, I don't know why I'm thinking about this. But okay, why don't I just get told the answer? I don't know why I even care about this, but okay, right. It is a measure of something across or through, and then I guess the circle part is implied. Okay. That's all I was curious about. uh, I guess I'm just gonna call it 24 centimeters. Hey, Eclipse, how's it going? And 24 centimeters is 0.24 meters. I'm doing good too. Thanks for asking. While I wait to see if someone has a question, I'm just doing some studying on electricity magnetism. Okay, so we can work out the surface area of the basketball now. Yeah, what's the question? We know it has negative 1,000 volts. And a volt, I have to scroll around the view. Maybe I don't need to find the formula book. Maybe I can work it out just from the units. Sounds good. A volt is a joule per coulomb. But I think it's also a coulomb per meter or something weird, isn't it? Like, there's 2 different versions. Equivalent versions. of the units for volts. If the remainder of 25 factorial divided by 23 factorial minus a is 60 squared, what is a? Or divided by a? $25 factorial divided by 23 factorial is a lot lower than 60 squared. Yeah, Eldritch. Oh, like that. Maybe I can figure this out. I don't really know. Okay. Well, I guess remainder of what? Now that I look at it more, or oh wait, if we oh, I see. So, I guess what we want to do is use the division, like, the definition of the division or whatever it's called, which is that 25 factorial is equal to 23 factorial minus a times some integer k plus the remainder of 60 squared. How do we work out? It's around 27 degrees with 35% right now. Oh, geez. It's getting like, I think today's around 100 degrees Fahrenheit. What is that in Celsius? 37.7 Celsius. So like basically 38. I'm a little confused on how we deal with this K. Could we just let K be 1 and solve it for A? Because there's probably multiple answers depending on which multiple you want. If we just let K be 1, let's see what if we get an answer that makes sense. I was about to write 2. So A here is, it feels like there should be some kind of like trick, I guess, that's not going to involve calculating 60 squared plus 23 factorial minus 25 factorial. But just for the sake of argument, let's put that into a calculator and see if it's like if it is a right answer. That's a negative number. That doesn't seem reasonable at all. Did I not solve for A correctly? No, I did. The answer is 6. Hey, Phobos. The numbers louder than they have exclamation point on them or what? Yeah, you have to yell it. That's exactly right. This is such a weird problem. I must be missing something because I feel like there should be many different answers because of this K. Let's just let's just, I guess, verify that answer that you said that it is a 6. Oh. Now, is that a rounding error? Or is that actually slightly off? I could see it being either way. Huh. This worries me. So I feel like it should have just been 600 on the dot here. And if Wolfram is getting this decimal, I'm kind of suspicious of how possible this is. I'm not very good at these types of problems in the first place. I should like make that disclaimer. What exam? Oh, this one is saying the AYT. Hmm. Factorial minus, you set up this thing, which you know is an integer. Which I guess is just a rearrangement of the thing that I set up. 60. You have to notice that 25 times 24 is 600? No way. I figure there must have been something special about being given 60 squared. Okay. So the way this is phrased does make it sound like there's multiple um solutions. That's kind of crazy. Yeah, so uh I don't know. That's a weird question, I guess. I've never been tested on having to do like questions like that before, I guess. So I don't really know how to approach them. Which I mean, I think I was like sort of right, but not really. Or I didn't know like where to go with the thing that I set up, which I think I could have made it work. Everyone hated that factorial question. Yeah. um, Rendition, and I've seen the problem sum before. Yeah. Oh, a field is a volt per centimeter? Is that the relation I was thinking of? In Gaussian units, anyway? Yeah, no worries. It Eclipse. Yeah, just as a warm up 10 bucks, I was doing this 2.6 question because it's a 1 star and it's seems pretty dang achievable, except I'm now getting caught up on the definition of the volt. I was trying to figure out what the other um type of unit thing is like over here that and I guess it's but like what is the field? It's almost a force, but not exactly. It's missing one of the charges. Newtons per coulomb? Maybe we could keep it simple like that. Hmm. I saw hard locked. Yeah. I opened up my OBS and like over an hour ago. I see you getting was it ultra first? No, super first. My bad. Congratulations though. Um how do you go? Okay, you know what? I'm glad that I chose this question because even with the units, I don't have a good understanding of them. Um What's up with, like, aren't Gaussian units easier to get to the actual count of electrons? Like, that's one of the things that they do well. I don't remember. I mean, I guess we have that conversion factor for coulombs. Straight to E. Um, dude, it's hard to think when it's this hot. Uh, it's minus 1,000 volts. We write down the conversion factor for E versus coulombs. (1.602 times 10 to the minus 19). I don't think we need a formula like that. We already know what the voltage is. That's what would want to solve for. Oh, maybe we do want this. Because we would know that phi is minus 1,000. You know, we treat the basketball as a point charge. What would our R be? RBs? Maybe the edge, like the surface of the basketball? What? Don't we have to assume? So yeah, we can work out the coulombs and then get to the actual count of electrons from the coulombs, I guess. Uh, what would we take? Waffle, what's up? You got the cat? Oh, that's awesome. If you feel comfortable, do you have a picture that you could post? You don't have to, but I am a cat enjoyer. You do? Ooh, okay. That's so awesome, Waffle. So that means you have two now? Gotta share pictures of... Oh yeah, please do. Week old kittens here? Oh. That sounds amazing. Same. Oh. Oh, it's the same type of cat? See, I'm bringing it up now. Staying here with all the cats until Friday? Oh, nice. Look at that little cat. That sounds great. Are you like watching them then, or why is there a whole like bunch of cats around? It sounds great. Oh, animal magnetism perk. Yeah. Your stepmom's sister breeds them, so you're staying with her for a while. Oh, nice. Yeah, I'd be looking for any excuse to like go over there. That's awesome. Thank you for sharing. Yeah. Uh, it feels kind of arbitrary to take the surface of the basketball as my issue. I'm trying to figure out why that's okay. Maybe that's just something that's implied by the wording of the question. I don't know. I guess let's just plug numbers in and see what we get. So yeah, 0.12 meters. So take minus 1,000, multiply it by those. What is... We need to know epsilon naught is the issue. Or... We can divide by k, I guess. I don't know what k is either. I need to go back to chapter 1. Found it. Just use that. So we're going to take minus 1,000 over 9 points. Oh, it's 8 point. It's 10 to the 9. And we're multiplying it by 0.12. How's it? I went straight to cats? No, please go straight to cats every time. I'm doing good though. On Sunday, I went rafting with some of my high school friends. It wasn't anything crazy, like not like water rafting or anything like that. Just kind of chilling on a river, getting splash fights with people, or like water fights, I guess. And it was a nice time. To charge at Q to get number, maybe. Let's call that 1.34 times 10 to the negative 8. Negative, right? Yeah. Minus 1.34 times 10 to the minus 8 coulombs equals Q. That's total charge, and they are asking for per square centimeter. Yeah. I felt a little bit bad because my friends wanted to like go a lot crazy. Like I just wanted to chill out on the river and like drift down it, and my friends wanted to like pick fights or like, you know, water fights with people and like make stops and like stuff like that. But I don't know. I think just chilling on the river and relaxing is a good enough time. This number doesn't seem unreasonable to me though, because coulombs are kind of ginormous. That's not a decimal. That's a supposed to be multiplication. And the area is 4 pi. I wonder if this would have just divided out that 4 pi anyway. Times r squared, 0.12 squared. Oh, yeah, I should do the conversion. I mean, it probably doesn't matter if we do the conversion first or not. Let's do the conversion first, though. So we're going to take this thing, minus 1.34 times 10 to the negative 8 coulombs, and divide it by 1. Well, let me rephrase that, and multiply it by 1.602 times 10 to the minus 19 coulombs per E. So, I did the exact opposite of what I should do. And I cut off that box too quick. Okay, there. Or I made too much white space on that box. Okay. So let's plug that in. 1.34 times 10 to the minus 8 over 1.602 times 10 to the minus 19. So we have minus 8.36 times 10 to the 10 E. That's not a brush. Yeah, and we have that negative charge in here. Because E is defined to be positive, I think. Weirdly. Because it's the charge of a proton, I think, for some reason. So something like that, at least. Maybe I have it backwards, though. But I think you should like take the magnitude of it. Whatever. I mean, I think I'm expecting a negative sign on the end result. So I think even with E, you need a negative sign for a negative charge, I think. But that's the total charge in terms of E. We want per square centimeter. I'm not too concerned about the negative sign, to be honest. Either way. think the point is getting the units right. Good point, $10. We need 12, not 0.12. Because they are asking for per square centimeter. Ah! But I was about to make that exact mistake, so... 4 pi times 12 squared. So final answer is minus 4.62 times 10 to the 7. Is that reasonable? In a square centimeter of a basketball with negative... I mean, I have no idea, but that's reasonable, I guess. I never counted the electrons on a charged basketball that's made of rubber, or whatever they're made of. It probably isn't very conductive in the first place. How many extra? I think that's built into the definition of volt, isn't it? Oh, you're because of a number of electrons? Okay. I mean I don't really care about the sign, but sure. I mean, no, I mean this is the charge. So I'm not going to change this because this is technically right. But if we want the actual number of electrons down here, yeah, sure, let's drop the sign. Okay, they use 0.3 meters, which is... What? If you know the actual value, just use the actual value. Why would you do this? I don't get it. For no particular reason, we're going to use an approximation when we know the actual number. Oh my god. There's more... Okay, yeah, I could use a cat picture right now to deal with my confusion at physics. Why is that there now? Didn't I don't know why I went over there. Oh, more pictures. They're so small. Oh, I should have looked harder. I'm being distracted by cats, though. You know, this should really just be a cat stream. That might be my true calling. No one tried to dox me with cats. This is a grumpy cat right there. I guess they all look a little grumpy. But like, especially like these two with their like facial expressions. Oh, that looks like some little cats right there. Aw. Yeah, we should just have like a cat picture like segment, I feel like. Oh, even more. Hell yeah. Love it. Even with a little like a TV like cutout. New ones are getting born while you're here. Oh wow, that's amazing. They stick an extra. Oh, I don't know why they phrase it like this either, where they make it positive and then stick a negative sign on it, but okay. The girl laying on the blue sheet is pregnant. Oh, like in this one right here, or maybe you're probably in this one. She's off to the right there. Or that one. I know. There's a lot of like blue sheets around, I guess. Yeah. Okay. Yeah. So that one. Oh, the first one. Okay. Okay. Yeah. Yeah. Every time I looked at the other picture, I feel like I saw a new blue sheet. The delays make it hard, but this one it sounds like. I guess she has a right to look grumpy then. Blue plastic, yeah. It's all good. Okay, so they do the per square centimeter thing first. But does this R really cancel with that R? Unless they're gonna working. Oh, okay, so they work in meters and then convert it to centimeters to the last second. I did not get that number. I got 4.61 times 10 to the 7. Is that a rounding difference? Oh, it's probably because of the 0.15. I got the right order of magnitude. How's that 8.85? Is that... Oh, that's just epsilon naught. It's the 4 pi's canceled out. Yeah, I think it's because of the 0.15 versus 0.12 thing. If I take their same formula and plug in 0.12, do you get what I got? Yeah, that'll be 4.61 after you convert it. Okay. It was just that stupid, like, why would you know the real value and then use a wrong value? That really annoys me. Like, it seems so ridiculous to me. Oh yeah, I think the approximation of 9 is like not bad at all. Hello to Colby over in the YouTube chat. Suppose X and Y are sets. Ooh. The induced set function? I'll paste it over to the Twitch chat in case someone... Suppose A is a subset of X. B is a subset of Y. Show that F inverse of B is a subset of B? A proper subset of B. Oh, F of F inverse of B. Does induced set have a special meaning? Or induced set function? I'm not optimistic able to answer this, Cole, because I'm just not that good, or like I haven't really learned how to do a question quite like this. I can read the notation and probably understand a proof, but inherited by the subset? Okay. A proper subset of B? That seems so weird. Like you have a function that maps X to Y. You have A as a subset of X. B is a subset of Y. Why would F of F inverse of B be a proper subset of B? Thank you, Waffle. I appreciate being blessed with cats. And hey, Tomas, you know the derivatives and integrals of hyperbolic functions? I mean, I don't have them memorized. I can look them up and work with them, but I don't like know them offhand. Yeah, Cole, I'm sorry. I don't know how to do this. Oh, okay. Your textbook says the following. F of A is equal to... This might be something. Tomas, I have no clue what this is called. It's called whatever Cole just put in chat. It is set theory? Okay. Maybe we can combine these definitions in some way. Introduction to topological manifolds. Oh, wow. Yeah, this feels like an SPQ type question. um, F of A, I mean, so if we just kind of blindly take this definition, and instead of A, we have F inverse of B, do we get anything? If we plugged it into the definition? Hmm. But like, can we just say that f of f inverse is just x? I'm kind of confused. Like, just intuitively, if this thing is true, doesn't that mean that some elements are getting dropped as we map back and forth? And that just seems so weird. Like, how do we permanently lose an element just by applying the function in one direction and then the other? Is the function f map the preimage of B? I don't get this. I feel like this thing can't be true, but I don't know. I I, I don't think I'm able to answer this question. You got a hint that was x belonging to f inverse B implies f of x belongs to B. Some points in B may not be mapped to by the function f. Oh. Oh, it doesn't have to be onto, does it? That's the idea. That's the question there, Kaizen. Your other hint was if y is in f of a, then there exists an x in a such that f of x equals y. So we want to name a function, or we want to name an element in B that f does not map to. What would an inverse function do with a point like that? Okay, Benbox is saying... where's my cursor? There it is, okay. Yeah, let me just copy and paste this because I don't have an original thought in my brain. Cole, this is what Fenbox put over in the Twitch chat as an idea. I haven't read it yet, though. LaTeX is free, you know? Well, I mean, LaTeX also takes forever, but you're right, syntax. If x is in f of f inverse of b, there must exist a y in f inverse b such that f of y equals x. Means that f of y is in b. Which means that x is in b. But we need to show it's specifically a proper subset. That's the part that's tripping me up. Like, I can see what you're writing, Kaisen. Um, and this seems like a good start. Like, I guess we need to make some point about how x... Like, I think this does... I think, from my reading of it, this proves that f of f inverse of b is a subset of b, but we want a proper subset, and I don't know how to do that piece of the proof. Consider the function s maps r to r, where s equals r squared. And the issue is that we have to make a choice of positive or negative root, I guess. So S of S inverse of 4 is equal to if you have the identity, then it couldn't be a proper subset. Tomas, I have a bachelor's in applied math. I've taken a discrete math class, but like I've never done anything that's like a problem that we're doing here, but I've seen enough things, similar things, that I can at least like read it and understand the logic if it's presented to me. I don't know how to actually do a problem like this on my own though. That's probably it, Cole, because of this issue here where there isn't like a unique inverse function, I guess. Hey, SPQ. I don't know, Kaizen. This seems like a undergraduate level math to me at least. Cole over in the YouTube chat asked this question. Oh, that's not the question. This question. And I've been, against my better judgment, trying to do it despite not knowing how to do these questions. And so Cole got a hint to consider a function mapping reals to reals, and that function being x squared, as well as to consider the definition of function and inverse, but I don't know how you piece these together. I've read a lot of stuff that probably doesn't mean anything. Um, it's kind of reflexive, RFL. X in F inverse of B, if and only if f of x in B. I mean, I'm kind of confused because the question is like with a proper subset, which I don't really know. Hey, Rengat, well, if you have an idea, please. Like, the thing that gets me is like it being a proper subset, I guess. That's the question, Renga. Hmm. Um, SPQ is saying, but then f of f inverse of b. Hey, Viv. Good evening to you too. Then f of f inverse of b is equal to y in y there exists an x in f inverse of b such that no the colon f of x equals y. But I'm just translating the I'm being a human LaTeX editor right now. I don't even quite understanding what I'm writing, but or renderer, I guess. In x such that f of x is in b. All right, that's what SPQ said. You're good at discrete math? Take your shot at that then. I'm not good at this. It's that the question is about being a proper subset, which I'm saying it doesn't have to be proper, which I don't know how to confirm or deny that. Hmm. It doesn't. It may be improper. Oh, okay. And yet, Tomas, that might be backwards what John Reed said. I always mix them up though. Surjective, injective onto. I thought injective was onto, but it might be crazy. I am crazy, I think. I should never doubt John again. That's like the quick explanation, I guess, for one-to-one onto, or injection, surjection, bijection. Okay, so there's agreement whole that it doesn't have to be a proper subset. So maybe is there more to the question or something like? The typo slash careless notation. That makes sense, because like uh that's been weirding me out this entire thing. The same kind of okay. Yeah, I'm sorry, Pinbox. I'm just going off like the number of people who are agreeing right now. So I don't know how to choose out the right answer for myself with this type of math. Surjective just means every possible output is mapped to. So over here in injective, nothing maps to this output here. Oops, I'm not showing my cursor. Over here in injective, this output here is being left out. Nothing maps to it. Over here and onto, every output is mapped to. I'm just going to drop the link because I am going to want to change my view. Yeah, cool. It might be an impossible question unless there's more to the question, because I'm only seeing 3 people now agreeing that it shouldn't be a proper subset. I'm not sure. Like you did put that example of x squared in there. I'll paste it over to the Twitch chat. But like I don't know how it's. I don't know what to do with it. The textbook uses funky notation. Oh. Yeah, SPQ. Wait, so that's what it seems like? What the hell? Some people write A subset of C. But A does not equal B. Oh. So it is the bad notation from the book. Their thing for a proper subset is that, it seems? That looks so weird. Okay, so for our notation, we can just, or I guess for the notation I'm used to, we can just put that bar there. Oh yeah, I've seen that metaphor before. I forget who said it though. Okay, so it does not have to be a proper subset. That's good to know. That's such a weird notation. Yeah, I guess the task is to deal with F not being surjective. I still don't know how you do that personally, but like I can see that the idea is to um take an element that's in B but not mapped to by F. I hope you have not been having any sinful, inappropriate thoughts. If so, pray for forgiveness. Oh god. I better spend the rest of my life praying then. You think the equality holds... Pray for consistent notation? Yeah. There needs to be... Praying hands. And only if... So the inclusion is proper if and only if there is a point B that is not in the image of F. Yeah, like we need, like, let X belong to B. And X not be in the, what was I, R? Not be in the image of F, I guess. A cat with no blanket. That's not a smiley face situation, Fenbox. Every cat needs a blanket. Should be a frowny face. This is serious when cats are involved. What is F inverse of B? Wait, I messed this up, didn't I? No, yeah, actually, no, this is good. I mean, I don't know what I do with this, but I think, like, this is how I would probably start it, in my uneducated opinion. You know what? I don't know why I'm not using this step problem thing. Because it's not working? Wait, what? Okay, A, I didn't get the right... I forgot to copy the problem first. B, why didn't it work? StreamerBot? It is running, it's just asleep? Oh, it's because of the scene. Okay, no. I'm not using that. I could set it to work on the scene too, but it would be annoying to do on stream. If someone wants to just like say the answer, like I'll pass along to Cole, but I don't know how you do this for myself, so I'm gonna move on if I don't see like. Yeah, SPQ they do. So I still don't know how you like show that it's a subset, but all right. See you in a bit, $10. Actually, can I set up this problem thing quickly? Let me actually try it. Where would I put it? I would put it there and there. I would crop it up to there. Make it not seen for now. I don't think this will be that bad. Display problem. Oh, that's not it. If you think basically that's the definition of pre-image and forward image. All right, cool. Sorry I couldn't really give you a good answer there, but I'm pretty out of my depth with that. So if you got it, then I'm glad. I'll paste over a few things that people are putting in Twitch if it does help, but no need to do anything with it if you feel like you already got it. I'm just saying one thing with my bot right now, and then I'm gonna find a problem to do. Bam. Bam. Also bam. Okay, does this thing work now? Hey, okay. Not only that important to have it on the scene too, but it's there now. Okay. Get that problem off my screen. Thank you for the help on that, by the way. Because I know next to nothing about set theory or discrete math or however you call it. Ugh. I haven't done algebra in a long time. I've been meaning to read chapter 5. How far did I get in chapter 4 though? Maybe I should do some algebra. Let me look at let me look at what Pensetter suggests for chapter 4 and figure out if I care if I miss out on that or not. I can't jump. Isomorphisms. Not too far. I've done 51. Oh, I was another like 10 problems or so. I've done 58. I think I've done 59. Maybe I think I've done 60. Probably done 64. '68 seems kind of familiar. 69. Hmm. Galleon. Dude, I'm so sick of chapter 4. But maybe I meant to do this off stream. Maybe I'll just read I'll just start reading chapter 5 right now though. What was 59? Oh, I forget. Oh, right. You might have helped me with that one. I think you did. You assume there's two elements of order 2, and you make a third element of order 2, I think was the technique. Yeah, Pensar has been on chapter 5 for a while. Permutation groups. I've just been super behind because the E&M has been so much fun, but I still want to do the algebra too. Oh my god, I've just been too lazy to actually read chapter 5. Must be independent chapter 4? Okay. Yeah, and even then, I'm only missing out on doing a couple problems of chapter 4. And chapter 4 is kind of lame to me anyway, so I'm not going to be heartbroken. I really just want to get into the isomorphisms, because I think that's where it's going to get a bit cooler. Like the higher level, like, things, I guess. Okay, groups of functions which map A to itself. Both 1-to-1 and on 2. Permutation group of a set A is a set of permutations of A that forms a group under function composition. Okay. Focusing on A being finite. How do you permute infinitely many things? I guess you can switch the pattern around. You don't have to highly computational, and so is this chapter? Okay. And you're taking A to be, the set A to be integers from 1 to n. Hey, calm cooking. Let me write out what you're typing. You're saying the integral of a to x of f minus c to a of f. Oh, okay, okay. Is equal to you're saying these two are switched? Ah, what did I... Oh my god. Stop! Frickin' who uses the stupid program besides Dan? Okay. C to x f dx. So yeah, this is a property of integrals, and I like to To me, it's a bit more natural to add this term to the other side. So I'm going to do that and then make a drawing of why this thing is true. Okay, so if you take any generic function you want, f, you know, that thing, and I'm going to arbitrarily say this is x equals a, and okay, well, we use x as our upper bound here. That's kind of unfortunate notation. The letter itself doesn't actually matter. Actually, x is probably the one letter you don't want to use for this. I'm gonna make it a b, but what you have is it may as well be the same. I don't really like using x here though. So the integral from x equals a to x equals b is all the area under this curve here. And all this formula down here says is that if you make an arbitrary partition in this curve and add those two areas separately, you get the entire thing back. And I'll show you what I mean by that. Because obviously I just use the word partition that we need to actually show what that means. I wish I didn't fill this in now. If I name a new point between these 2 points, and call it x equals c, and I get the area on the left, and add the area on the right, well, these two things, or these two areas just add up to the entire area in the original integral. Yeah, okay, cool. You got it when I added it? Okay, good. Mean value theorem? I think this is used for mean value theorem, yeah, or something like that. No worries. Thank you for the question. Bro, I can't integrate shit with okay, first year calculus student. Rolls? Maybe. Honestly, I get a lot of those theorems mixed up. There's a lot of them out there. All right. Back to permutation groups. We're continuing to express the correspondences to array alpha in array form as input in the first row, output in the second row. I have a bad feeling that linear algebra is going to be involved here. Oh, what is this? Composition of permutations expressed in array notation is carried out from right to left by going from top to bottom, then again from top to bottom. Okay, so if we have two permutation groups acting on the same set of integers, but permuting them differently, and we compose gamma of sigma, this is gamma, this is sigma. So you go right to left. So you start with sigma. You start with 1. 1 gets mapped to 2, but then 2 gets mapped to 4. So your real out. So if you give it this composition of 1, that 1 gets mapped to 2, then that gets mapped to 4. So really, you just map 1 right to 4. Okay, that makes sense. The explanation of it is wordy, but if you actually follow logic, it's not that bad. Can't seem to find a reference, but I think symmetric groups on infinite sets are very limited interest. Oh, interesting. Okay. What's the difference between a Darboux definition of an integral and a Riemann definition of an integral? That's a good question. So they're very, very similar. If you take a Riemann sum, you have a choice of doing a left, right, or midpoint Riemann sum, or middle, or whatever the commonly term used is. Or if you do a Darboux, I guess I'll call it sum. I don't know, like sum and integral. I'm kind of using it interchangeably here. You can do an upper or a lower, and what that means is let's take our generic function f again that we know and love. It's definitely not a cubic, or actually it definitely isn't a cubic, right? No, it is a cubic, or would be, or it could be. But anyway, if we were to do a left Riemann sum on this, let's make some bounds a and b. Actually shift this entire thing up as well. Left Riemann sum, and we'll just make it with 4 intervals. So we divide this thing up into 4, and on each of these intervals, we just always choose the left part of the function, which I assume you're familiar with. And for the picture, it's not necessarily clear if this is an overestimate or an underestimate, because like this first one underestimates, this first one overestimates, and underestimates. You just heard about partitions? Okay, nice. But if you go now to, we'll take an upper Darboux sum, why not? Not drawing it quite the same, but it's supposed to be the same function. You divide it up into your same number of intervals, or partition it. This time, instead of always taking the kind of like the left-hand side of each interval, we take the supremum, or supremum, I always pronounce that wrong. So whatever the highest point in this interval is, we take that. So here, it's going to happen to be the right side. Here, it's probably going to be the left side. But whatever the highest point of the function is here. We'll do the left side. And in this last interval, we'll do the right side. And that's how you make your choice of interval each time, whatever your highest value is, and it guarantees you an overestimate. Whereas a Riemann sum, it can be iffy. What's an overestimate or underestimate? Hey, Anders. You hate Riemann sums? It's ugly. The height is the springy thing, the Greek letter. Oh, are you using I've heard it pronounced different ways, Kasai or C or something, but it's like that one? Or wait. Is it that, or did I do it backwards? I think it's the first one. That's my least favorite Greek letter. I hate it. I didn't use it for this purpose though. Wait, no, I did do it backwards. Let me. We have technology. That bad boy. You find it really elegant? I find it really annoying to write. What will be the formula? So the thing about a Darboux sum, it doesn't have as clean of a formula as a Riemann sum does. Off the top of my head, I guess you would write it as like I'm trying to figure out what it'd be right now. B minus A over N for the width from I equals, let's just say 1 to N. So if N equals 4, you have 1, 2. Okay, yeah. Of F, I assume you're using C, Kasai. I'm saying Kasai because that's how it's taught. Here. So like I guess you could call it this, but you'd have to like give a little caveat that like you have to say what Kasai is, which is it's whatever gives you the maximum value for F on that interval. So I don't think there is a clean way to make this formula like there is for a Riemann sum. For an upper sum. For a lower Darboux sum, it'd be the minimum. I should just be typing this. You write as an epsilon with a little thingy above and a long tail below. Oh, like this style of epsilon? Yeah, I guess it basically is. I heard the Darboux also takes partitions, and the lower and upper partitions get more refined as it gets closer representing. I don't see how in Riemann that happens as like taking in lower and upper. Right, inside of each partition is where you do the left, middle, or right, like exercise for a Riemann sum. So if you put it into 4 partitions like I did here, you would always take the left side in each interval, or you'd always take the middle, or you'd always take the right inside of each of these. So like this left-hand one would be B minus A over 4 times your first value is F of A. Your second value is F of A plus I guess b minus a over 4. Which would go with like whatever that line is there. Exactly, yeah. Whereas for Darboux Sum, you get to float wherever you want inside of each interval. It might be in the middle, it might be on the end, and it'll be different for each one, or it could be different for each one. So that's why it's a lot harder to make a universal formula for a Darboux Sum. Yeah, trapezoids are better. But for the purpose of defining an integral, Riemann sums are fine as well. Can be different width, but same side. Yes, I'm using a uniform partition size. Like I'm making them always the same width, which is what like this formula is assuming. You definitely are allowed to make your partitions different sizes. It makes things messier, but there's nothing invalid about saying I'm gonna make one of my partitions here, and then I'm gonna make, 3 more partitions inside here, or whatever. So it gets taught differently in different classes, but if they do allow for different partition sizes, the way that I was taught is you define P to be your biggest partition, and you do the limit as P approaches 0. So whatever your biggest, maybe from the right, I don't remember if they included that or not. But either way, everything is, you're always gonna make these things approach 0 when you go to actually define an integral. But yeah, you're absolutely allowed to have different partition sizes. How do you define an integral from here? Like, probably just like P times F of something. Like P sub I times F of X sub I. Like, probably just keep it simple. Yeah, because the largest one going to 0 forces all the others to be smaller. Normally they use delta x if they keep it consistent, or this P thing was only used for this purpose of going from a Riemann sum to an integral. Usually delta x is the more common thing. But your delta x could like change in this. P is the modulus of continuity. It's in the, I never heard the term modulus of continuity, but it is the biggest interval. So if modulus of continuity means the same thing, sure. I think that's, that definition is probably missing something, but an integral could be defined like that. And you can construct it with Darboux sums or Riemann sums. Gives you the exact same result. Sounds good. No worries. Shout out to Zach, by the way, for teaching me what a Darboux sum is. Because before that analysis class, I had never heard of it. And I'll just leave that there. When do I do live homework help? I do live homework help Tuesdays and Thursdays, starting about 2 hours ago, whatever that is in your time. On Saturdays, I do this reading group, and then I switch to math help in like 7 minutes from now or so. What was like? There is another person on YouTube who does math help like this too. And actually, that's the person who taught me about Darboux Sums. I need to remember what the command is though. YT math. Is that it? Oh no. Did I not set this command up right? YouTube message. Why didn't it trigger? I don't know why it didn't trigger. What if I test it? It's okay. YouTube. I don't know why Shimmer but doesn't want to work for right now. I didn't set it up for Twitch. I only set it up for YouTube. But that's another person on YouTube who does math homework help. Tuesdays/Thursdays at 1 p.m. Pacific. Saturdays at 3 p.m. Pacific. On Saturdays at 1, I do like a physics like reading group. I believe he does it on Fridays. At 11 a.m. Pacific. I took me out in chat too, just like give that to you. Let me actually look at his schedule. Yeah. This Friday, I'm not sure. But if not this Friday, then next Friday. Oh, really? Okay, well, he did one YouTube stream at least. Maybe he isn't gonna do more. Yeah, same, Anders. I've been meaning to read Chapter 5 off stream for a super long time. But I haven't done it, so I'm trying to read it on stream in my spare time. So there's a website called twitch.tv where there's a much... that's like, I consider my main streaming platform. It's more focused towards gaming, but there is this really cool like math community of streamers over on Twitch. So it's just like a live streaming website. And if you are interested in looking more at Twitch and like potentially making an account, there's many more people that I can recommend to you. Is that going to work? What? I've never updated my Nightbot. Dude, I need to... There's even more people that than that. Let me... Math streamers... Get... Oh, wow. All the people I added onto that list, I do that list by alphabetical order, and all the people I added on most recently are like the last three. Funny. Yeah, there's a whole bunch of Twitch channels that I can recommend. Unfortunately, on YouTube, it's kind of thin. I've looked before, and I saw one person who does it sometimes. Yeah, there's a whole like little community of us. I'm the one who like dual streams to YouTube as well, though, unfortunately. Like regularly. No, Telos only ever does gaming and will do a math question if someone asks. So yeah, like Talus's first emphasis is the gaming. No worries, cooking. Thank you for the questions. But yeah, Dan does kind of a similar thing. I mean, Dan does some dedicated math streams, but often like Dan will play a game but be open for questions. Yeah, exactly. So if you just want a stream where you can kind of like watch someone do math, then Talos' stream most times probably isn't for you. But Talos is a super funny person, and I like his stream. But yeah, if you're streaming math specifically, then you don't have a question, then the other streamers on the list are probably a bit better. All right, so S3 is a set of all one-to-one functions from 1, 2, 3 to itself. S3 under function composition is a group with 6 elements. Is that 3 factorial? How many? Oh, of course, because how many permutations of 3 things are there? 3 factorial. Okay. It's not abelian. So we're definitely not guaranteed abelianness. The relation beta alpha equals alpha squared beta can be used to compute other products in S3. I thought I was ordering into arrays. What? Beta alpha squared is equal to beta alpha alpha. Beta alpha is equal to alpha squared beta times alpha. That's to the 4th of beta. And alpha to the 4th is equal to just alpha. Because you have like a cycle of these 3 things. Starting from here, so you take alpha to the 4th, you go alpha 1, alpha 2, alpha 3, alpha 4. Okay. Symmetric group of degree n. Not order n, degree n. There are n choices. It is either to be the order of S sub n, just n factorial. Oh, okay, yeah, and they're showing why it's n factorial. Okay. Wait, S is non-abelian when n is greater than or equal to 3. I thought there was some kind of discussion about a group of order 3 has to be abelian. Oh, n is an order. That's an important bit. Oh, the order is n factorial. Okay. That's gonna be confusing that we use n for both order and, I guess, degree, but okay. S4 has 30 subgroups. Really? What? 4 times 3 times 2. Is that not 24? Am I stupid? S sub n. Oh, subgroups. Oh my god. I am stupid. Okay. I wonder if they're going to talk about how to get those subgroups then. I guess each unique swap can define a subgroup, I wonder? Like you can take it as a generator? I don't know. I don't think that. Oh, it is right? Okay. I will say it's probably not right. Will that mean, will that match with S sub 4 being 30 subgroups though? And you can generate more than one element. Fair. Wait, if you take a swap and compose it with itself, yeah, that's only order 2. Okay. It's more if you compose it with other swaps. Because otherwise you're just going back and forth. Like you're switching the 2 and the 1 back and forth infinitely or whatever. Oh. So there's a connection here with D4. Interesting. And so a rotate and a reflection can define the entire, or can generate the entire group. Not define, but generate. Okay, fair. Oh, Koshi, shout out. Penn Center is stranded in the airport like Tom Hanks. Yeah, I feel bad for Penn. I just saw his announcement that his flight got canceled for a second time. Like, yeah, guys, check out Koshi over on Twitch. I wonder who has that username. Does seem like it's taken. Three to four, 4 to 6, 6 to 3, 5 to itself. Okay. Yeah, it seems like a pain to do it for anything that's not a small group. Oh, okay, that's much more convenient. Like this thing here. Oop. Why are they starting with 2? 2 to 3, 3 to 1, 1 to 5, 5 to 2. Why can't we start with 1 to 5, 5 to 2, 2 to 3, 3 to 1? I guess it's equivalent. I don't like not starting with 1 though. Like, why wouldn't you do that? And they start with 6 for the second one. Okay, fine. Oh, okay. Or the... cycle length M or an M cycle. A multiplication of cycles can be introduced by thinking of a cycle as a permutation that fixes any symbol not appearing in the cycle. What? The cycle 4, 6 can be thought of as representing the permutation. Oh, okay. Okay, now that I've seen this, I know what this means. In this case, cycles commute, but it's not always the case. Oh. So there's situations where it's not necessarily the same to do these. I love that video. Zach, thank you so much for the raid. I that applied math lab that you've been going through looks sick, and I feel like I want to do it at some point too. Um, and actually, a special shout out to you. Someone earlier asked about the difference between a Darboux sum and a Riemann sum, and I was able to answer them. So yet another way how your analysis class helped. it did, yeah. Yeah, I see you're just on break. You're gonna be going again soon though, right? If you need to like get out of here and go like rest, please do. Right now I'm just doing some. I'm trying to catch up on the algebra reading group, so I've been too preoccupied with E&M. So what you're gonna do? All right, sounds good. I appreciate the raid. Okay, so we're just talking about how, in this case, you can put this cycle second or first, but that may not always be the case. Which I feel like, I wonder what one that's not going to be true, because if it holds everything else fixed, then they shouldn't, the order shouldn't matter, but take a guess. Well, if there's overlap in the numbers, well, no, but then they'd be the same cycle. It has to do. Oh, oh yeah. Benbox, the 3 months of Prime. Thank you so much. I really appreciate that. Um, Maybe it'll be a swap, or sorry, that's like a slide, I guess I'll call it, or a rotation if we're talking about dihedral groups versus a flip. Maybe those don't commute. I guess we could even try it, but like would would rho phi equal phi rho? Actually, they said it doesn't, right? No? That's something else they said doesn't commute. Gamma status achieved. No longer a beta. Congratulations. I guess we can actually try this. All right, so let's figure out rho phi. So we start with phi. 1 gets mapped to 2, 2 gets mapped. Oh, wait, well, let's do 1, 2, 3, 4. We feed a 1 into this composition Frankenstein permutation. 1 to 2, 2 to 3. So 1 gets mapped to 3. 2 gets mapped to 1, 1 gets mapped to 2. 3 gets mapped to 4, 4 gets mapped to 1. And by elimination, 4 goes to 4? Really? Yeah, okay. Whereas phi rho, we feed a 1, 2 to 1, 1. Oh, okay. So wait, I need to put it into the notation though, right? This wasn't actually the question. I'm just finding that they're not abelian, but we already knew that, right? Is that the same thing? Phi rho, God. Busroda. Hey Jen. 2 to 3, 3 to 4. 3 to 4, 4 to 3. 4 to 1, 1 to 2. Figaro, Figaro, Figaro. Oh, I get it. So I got, like, if we were to put this into the notation that we're just seeing, 3, it will be 3, 1, like that. And then 2. Oh wait, these are both. So I feel like I think I was I don't think I needed to test this abelian thing. I could have just like worked with just this one thing and then 2 and 4 can be omitted. Okay. So yeah, I did not find the right example then. I should just maybe work directly with this cycle notation. What would it be though? Because I feel like it would only be like, it's not valid to have like 2, 1, 4, and then 3, 4. Like these aren't well-formed cycles if 4 appears twice, I don't think. it would violate the one-to-one or on-to thing if you could make a cycle like this. So it's not that. Well, everything I've seen so far does commute, I guess. Like, we don't have that many samples to work with, but well, yeah. But we're talking about the commutativity of like this cycle notation, I guess. I think I was confused when I was doing this phi and rho stuff. Like, I think my question is actually, is it possible to have like go from the cycle notation, like if we had 4 1 3 2 5, is it possible to have two two otherwise same things, but you flip the order, produce different? Wait, but like, is there ever a world where like you have a situation like this where they make two different um matrices? I don't know how you read it when it's like this. Does this mean that, wait, 4 gets mapped to 1 like that? 1 gets mapped to 3. 3 gets mapped to 4, I think. 2 goes to 5. 5 goes to 2. I said that backwards, but I did it right. But like, I think if you swap these, I can't imagine a situation where you'd ever get a different thing. Like, is there a situation where that happens? Maybe they'll say that later on in the book anyway. Oh, okay, okay. That makes sense then. Oh. Are there supposed to be commas in here? Like, that's not 13, but 1 comma 3, I think, right? Oh, okay, yeah. Cats and blankets. Oh, true, Fembox. I didn't even think of that. Uh, I I love that rant from Pulp Fiction, but I also had to cut it short because Tarantino uses certain language. But hard luck. Thank you so much for the 500 bits. I like I probably should drink some coffee, but I don't. It's just like the heat. It's making me tired. Um, this turned into a mess. Yeah, Alpha Beta does. Oh, oh, you're talking about Pulp Fiction? Yeah, that's when they need to get their car cleaned out. Jackson was on brain duty in the backseat. uh, Wait, seriously, Anders? Or is that a quote? Oh, holy crap! That's horrible. Did you call the police or like? Yeah, I've never had anything like that happen to me. Police were already there. Oh, okay. Dang, I'm sorry you had to deal with that. Or I'm sorry that you like had that happen. Partially covered. Okay, that helps. Yeah, I don't think I've seen a dead body in real life, and I'm kind of grateful for that. Uh, Man, that's sad. At Wakes. Oh, yeah, that's true. Um, Yeah, my family doesn't really do that, like open casket thing. We didn't really have like formal wakes. We just like gather at someone's house and basically drink. My family isn't the most like reverent of people. Um, so how are they doing this thing here? 5 fixes 1, 6, 4, 8 fixes 1. This sends 1 to 2. 8 fixes 2. 4, 5, 6 fixes 2. 2 gets sent to 7. And 1, 3 fixes 7. So on the whole, 1 gets sent to 7. Oh. Okay. Yeah, critical. They use matrix notation for this stuff, but the thing that I'm studying here is completely different. Previous also first was terrible. Oh, okay. Yeah, I imagine it will be pretty freaking terrible depending on the circumstances. Yeah, I mean, I'm curious if they're going to use some kind of linear algebra idea down here, but they're talking about like permutations, and just this matrix notation is a convenient way of defining a permutation. Um, One day we'll conquer death. I mean, yeah, I mean, that depends on the definition of conquer, I guess, but it's a part of life. Some authors compose cycles from left to right. Oh no. This is like the subset notation thing all over again. Now they say multiply permutations, but in abstract algebra that means compose. I think that's how I'm interpreting that. Oh, were you there for it? I don't think you were there for it, Anders. But someone asked a question, and their book uses So this is the notation for a proper subset as I learned it, and most people in chat seem to have learned it. But this person's book says that is a proper subset, and I think these two just mean the same thing, just like a normal subset. Wishful or ominous? That's true. Yeah, there's a dark interpretation there, but it sounds like one of those like prophecies that gets like twisted on you. But yeah, apparently this notation exists for a proper subset. You've seen both? Okay. It was new for me at least. Mm-hmm. 153, 2, 4. I feel like I've already. I can figure out how to do this. I don't need another example. To write cycles out of only one entry, any missing element is mapped to itself. Okay. Oh, so for the identity, you just have it as a single thing? Okay. Now I mean, I guess back to that kind of infinite permutation set thing, you could, I feel like by this logic, or like, by the petition they set up here, you could consider all of these as infinite, just everything after 5 in this example is fixed. Maybe that's kind of the point that they're making. Like, you could extend this from 6 to infinity and just keep all those numbers in the same spot. Oh. Without that they're willing to leave off like single things. But probably not important. Every permutation of a finite set can be written as a cycle or as a product of disjoint cycles. Oh, the playlist looped. How long has it been? Oh, 2.5 hours apparently. Let's do this song. Let's read this proof. Write alpha in disjoint cycle form. Let A2 equals alpha A1, A3 equals alpha alpha A1. This alpha and A thing is going to get confusing. I'm going to misread something at some point. Alpha 1 equals alpha to the, or A1 equals alpha to the M A1, where N equals J minus I, sure. Really boring proof, but fair enough. Disjoint cycles commute. Okay, that was the exact thing we were asking before. So, can they have entries in common? I feel like that contradicts how we've constructed these. This proof up here is neat. I don't know, this feels kind of mechanical to me. Maybe I just don't have an appreciation for it yet. I don't know. I don't see what was like that hard about that proof, I guess. I mean, I'm saying I would have come up with it for myself, but like, it's kind of like, yeah, sure, we can just keep taking alpha, whatever the last thing was, and then just choose a B that wasn't in that cycle and apply alpha to that. I don't know. Alpha beta of a sub I is equal to alpha beta of a sub I. Ooh, beta of a sub I. Oh yeah, so beta holds a fixed. And alpha a sub I is equal to a sub I plus 1 by definition. Okay. Cycles constructed in that way will always be disjoint. Okay. But I feel like if they aren't disjoint, then something's gone wrong. So I don't know if this chapter is gonna get into that, but I'm still left wondering. Yeah. Hey, Gold. I'm trying to catch up with Penn Center's reading group. I've been a full chapter behind for like a couple of weeks now, so I'm trying to catch up on reading it. We've been talking about permutation groups. Honestly, I'm trying to get through it though until we get to like isomorphisms and stuff that I think are probably going to be more interesting. If they're not disjoint, then you don't know they'll commute. Yeah, it just feels like the idea of a disjoint cycle in the first place is just weird. Like, I think we should just be in the universe where it's always disjoint. I don't know. It's just a frame of mind thing. All right, that proof works for me. Well, that part of the proof. Oh, and then for C, of course, they both hold C fig, so who cares? Okay. Eyeball the order of the permutation. The order of a permutation of a finite set written in disjoint cycle form. The least common multiple of the lengths of the cycle. The order of a permutation of a finite set. What the order of a permutation of a finite set? What does that even mean? What are we saying this thing is? The number of permutations there are? That was the thing that's confusing with degree versus order. But this actually is the number of permutations, like the number of functions that we're composing with. The order of permutation is an element of the group? Oh no. Oh, the order of the group it generates, or as in the order of just the element itself. Okay. So this thing right here is not considered disjoint cycle form because it's not simplified like this thing here. Because these two things are equivalent, or they refer to the same permutation cycle. Identity, I think. Unless there's like a specific one for permutation groups, but okay. So the LCM of these would be, I mean, we have 4, 2, and 2, so 4 is the order of this cycle. That makes sense. Oh, because this thing right here, oh, you'd have to do this one thing 4 times to make it go back to the original order. And because 4, 8, and 5, and 6 are length 2, you're just swapping them back and forth twice. Okay. That works. First, observe that a cycle of length n has order n. Verify this yourself? Nah, like it's not. Is that not just like the definition? A cycle of length n has. Yeah, no, that's. I'm calling that trivial. It's an exercise left for the next chump reading this book who's not me. Suppose alpha and beta are disjoint cycles of lengths m and n. K be the LCM. Oh, so this is relying on the commutativity of this disjoint cycle notation. And okay, yeah, that is another. I didn't put it together, but that is another form of composition. Oh. Okay. So they care about disjoint cycles. I didn't really put two and two together. This alpha beta thing we were doing is the exact same the composition of like phi and rho and all that stuff. Okay, that makes more sense. So this implies alpha to the t equals beta to the minus t. Okay. Okay, this is a little weird to wrap my head around, but I think I kind of get it. They have to both be the identity. Okay. Identify with things powerful tool calculating the orders of permutations. And permutations of a particular order. Six, four, right, six. Oh, it's not simplified because it's not disjoint. That's mean. If they have a problem like this, like down but below that, that's gonna get me. I'm gonna forget to simplify it. The orders of the 50-40 elements of in S7 we knew like is a possible disjoint cycle structures of the elements of S7. Known n cycle by n underscore. What? Oh, these are partitions, aren't they? I didn't notice that. Yeah, I know I've seen Stuki talk about this exact like or talk about like partitions of an integer. What an emote combo. So you can have okay, so in S7, which is all the permutations of seven things, you can write a single cycle of length 7. Yeah. You can have a cycle of 6 followed by a cycle of 1. Sure. 5 of 2, a 5 of 1, 1. Yeah, it's just all ways to add to 7, I guess. Okay. Seven, 6, 10, 5, 12. Okay. To the same for 10 factorial will be nearly as simple, but it's going to get a lot harder pretty quickly. A number of elements of S7 of order 12. We only count the number of permutations with disjoint cycle form 4, 3. Why not 6, 2? Because that doesn't add to 7. Counts the cycle 4 times. Oh. It's kind of gross. How these are actually the same thing, just permuted. That's probably a poor choice of words. They refer to the same permutation. Hey, 420. Interesting. So you have to divide by the cycle length for each of these. Is that n factorial? Oh, no repeats? Like n factorial over n minus r factorial, or whatever that formula was at some point was? Permutations with no repeats. Aha! I have been taught this in a different context. Go away. Okay. Yeah, they keep putting things in random orders. Renga, it's been a little bit confusing, but I think they're trying to emphasize that there's nothing unique about putting the least integer first. How long is this chapter, by the way? I'm on page 124. Oh, geez. I saw an atom. All right, another like 10 pages. Example 7. You can skip the application section. Oh, I didn't even see that there was one. That looks like an application. I'm ready to do Rubik's Cube part, but yeah, I don't care about a lot of this. My math background, I have a bachelor's in applied math. And I specifically avoided, as part of my degree, any type of proof class. So I couldn't get out of discrete math, but I avoided number theory like the plague, abstract algebra, I avoided. Topology, stuff like that. I avoided. I like the applied stuff much more. Yeah, I avoided analysis as well. But I've since done Zach's real analysis class, and I'm reading along with Penn Center's algebra reading group, so the joke's on me. No fun at all then? To me, it's all fun and no lame stuff, but... To be fair, the professor at my school for a lot of those classes, uh, the dude was insanely smart, but he did not care about teaching undergraduate level math. He would like vomit a proof up on the board and just like let you deal with it. He seems like a cool guy outside of that, but like his teaching style was really bad. Like he should have been teaching graduate students. Applied math makes you nauseous. I I don't enjoy math if I don't see the point. There's sometimes some like neat tricks and proof that improves and stuff that I can appreciate, but like uh even this like abstract algebra, I'm waiting for it to get interesting still, I feel like. Well, growing proofs is just having to deal with it. I ain't fair. Or you can just, not do proofs. um yeah, we skipped all shit in my undergrad class. Like we're just talking about skipping the applied section of this chapter. Um, I don't know. Apparently, abstract algebra comes up in like quantum physics in some weird way because there's a lot of like symmetries involved. But um, I'm more just studying this now because grad school's a goal of mine, and they're gonna make me do stuff like this. Why does that? I feel like the alerts are cutting off slightly too soon. I need to look back at my stream roll once again. But hard luck. Thank you so much for the 100 bits. I appreciate you. That was one of my first alerts too. I think Jed suggested that one. All right, thanks for lurking, Joseph. When I went to college, my degree is in pure math. I felt like that was somehow above applied math. Since changing my knowing of all the stuff I can use your math and science and engineering. Yeah, same. Well, I didn't start in pure math. Technically, I started in engineering, but the school's program for engineering sucked. And I just liked the math part anyway. Chemists and chemical engineering friends were references. Oh, interesting. I'm still trying to work out why we need these, like why we need both of those. Yeah, I was thinking, I mean, technically that's Josep. The H and the P were switched. Um, an S7 of order 3. I guess they're disjoint. It just lame to me that this is order 3, I guess. I don't know why in this situation it's lame to me, but... Talos? What is that? Oh, that's such a good emo. What the hell? Is that new? Oh, it looks great. Your emotes have been like crushing it. That lick one is really good too. You know, it's like a one person raid. I'll take it. You lost, but with the Taco Bell thing? Okay. The Nina, the Pinta, the Santa Maria. Ugh. Why do they make students remember the names of those ships? That feels like such useless information. Quit chess. Remember from Step Brothers? I never watched it. That's what Christopher Columbus's ships, right? It wasn't like the one the Pilgrims landed in, or maybe it was. No, that was the Mayflower. Yeah, those were Columbus's ships. Those three ships. Uh, the big husky. GTM on cryptography. What is it, like a podcast or something? Harlech, if you're around, do you want to sit some Phasmophobia? I well, I was thinking about messaging you before, but I thought I'd be like too lazy by this time of day. It's no worries if not. Like I'm happy to do it another day. Graduate text in mathematics. Oh, okay. So I'm starting to be able to like not think anymore. Ugh. Oh, that's too good. Yeah, I'm sorry, everyone. Like, but it's too hot for me to think, and this is like it's making less sense the more that I try to think. So it's too hot today. If you're interested in more math, Gold just started streaming now. It looks like, or at least like recently, and Zach is going to be going, I assume, in the relatively near future tonight. Uh, Actually, are you good to go now, Hardluck, or do you want some time? So I realize just kind of like randomly asked you out of the blue. You're good? Okay. Yeah, let's switch. I'm my brain has gone bye-bye. Obi's on too? Oh, I didn't even see. Yeah. His avatar blends right in with like my light mode background. All right, I'm gonna stop the YouTube stream here. So if you're on YouTube, I appreciate you. Be back on YouTube on Thursday.